In this tutorial, I'm going to be going over how to create a spreadsheet in Google Sheets. The spreadsheet that we are going to be creating is going to be referencing our gear ratio assignment. In our gear ratio assignment, we are trying to calculate the gear ratios between these gears found on a bicycle. Let's jump over to our Google Sheets and create a new spreadsheet. Once you're in Google Sheets, you can create a blank spreadsheet by clicking on the plus button. Once you've done that, you will notice that this is the workspace in Google Sheets. In the bottom left-hand corner, you will notice that we currently have one sheet that represents our entire spreadsheet. You can add additional sheets to your spreadsheet by clicking on the plus button. You can add as many sheets as you would like, as this will help better organize your data. In addition to this, you can also rename your sheets by right-clicking on the sheet and going up to rename. We are going to rename sheet number 1 to gear ratios. After you type your name in, press enter on the keyboard. If you have created additional sheets, you can delete them by right-clicking on the additional sheet and going to delete. Your spreadsheet is divided up into columns, which are represented by the letters in the alphabet. Your columns will go from left to right. In addition to having columns, you also have row numbers. Your row numbers will go vertically. The intersection point between a column and a row is called a cell. Each cell has a cell identifier. This particular cell's identifier is A1. If you click on a random cell, notice that the column will highlight a darker gray and the row number will highlight a darker gray. This particular cell has an identifier of E15. This is very important when you are using Google Sheets to calculate mathematical formulas. With that in mind, we are going to recreate our table found in our gear ratios assignment. You can type in alphanumeric data into each cell. However, if you are going to be using that cell as part of a mathematical formula, it only needs to consist of numbers. With that in mind, we are going to start our spreadsheet in cell A1. And A1, we are going to use that as our label for our cassette cogs. We are going to type in the label of cassette cogs, and these are measured in teeth. Notice when I typed in that information that my data extends a little bit beyond column A. You can resize your columns by clicking on the vertical line that exists between each column and drag it over. You can auto resize your columns by double left clicking that vertical line. Once you have your label in place, we are going to start typing in our data into cell A2. Once you type your data in, you can gesture your mouse over to cell A3 and click in it, and that will select the next cell. A faster method is to actually use the arrow keys on your keyboard to select the next cell. We are going to type in all the data from our table into our spreadsheet. Once you've typed in all of your cassette cogs, now we are going to go up to cell B1 and start typing in our chainring sizes. Notice we do not have a label for these. We can go over to our row number 1 and right click in it and go down to insert one row above. We are going to choose cell C1 and we are going to type in chain ring, and these are also measured in teeth. Now that we have all of the data out of our table, we are going to start typing in some mathematical formulas. In Google Sheets, a mathematical formula always starts with the equal sign. We are going to go up to cell B3 and we are going to start typing in our mathematical formula. When talking about calculating gear ratios by its teeth, it is our output gear, which is our cassette gear, divided by our input gear, which is our chainring gear. We can reference our cell that our data exists in by just clicking on it. So we are going to reference cell A3 by clicking on it. After you've referenced cell A3, you're going to type in the division sign and then click on cell B2. Notice our formula now is the information that's in cell A3 divided by the information that's in cell B2. To enter this formula, you will press the Enter key on the keyboard. Notice that it automatically calculates that information for you. If you go back up to cell B3, you will notice this blue box in the bottom right-hand corner. If you left click and hold down on that blue box, you can actually copy that formula all the way down to your last cassette cog. And notice automatically the data will populate. However, there's an issue. If we go down to cell B4, you will notice that A4 is being referenced as our output gear, but our input gear is the solution from our previous gear ratio. This is not correct. What we need to do is we need to put a relative identifier in. In Google Sheets, the $ is used to represent an absolute or relative cell reference. Using the $ before the column letter will reference only data in that particular column. Using the $ in front of the row number will reference only data in that particular row. Using them both together will reference an exact cell or an absolute cell. With that in mind, what we want is we want to represent this particular row. So what we're going to do is go back into cell B3 and we are going to place our cursor in our formula bar here in between our column letter and our row number and enter in the $. After you enter in the $, press enter on the keyboard. We're going to select cell B3 again and drag our handle down to copy our formula again. Notice our data is now accurate to what you have calculated in your gear ratio assignment. Once you have your formula, you can copy this formula into the other cells by just dragging it over. However, notice once we drag it over into our next column, our data has changed again. Let's take a look again at our formula. If we select cell C3, you will notice that B3, which is our solution from our previous chainring, is being referenced as our output gear. We do not want this. Again, we need to use that $ to create a relative reference. What we're going to do is go back to our original formula found in B3. However, this time we are going to place our cursor in our formula bar in front of the letter A and enter the $sign. What we've done here is we've told our spreadsheet that we only want the information found in this particular column to be used. After we've entered in that $sign, press enter on the keyboard and drag your new formula down. Notice our data has stayed the same. Once you have that new formula, we can copy it over, and notice our data is now accurate. We can copy it again over to the 22-tooth chainring. Now we have calculated the gear ratios for our bicycle. Let's jump over to our gear ratio assignment and check out the next problem. Question number 2 indicates if the above drivetrain was attached to a bicycle with a measured wheel diameter of 29 inches, what is the distance per revolution the bicycle will travel? With that in mind, let's jump back to our spreadsheet. What we're going to do is go to row number 1, right click on it, and go to Insert One Row Above. In cell A1, we are going to put a label as wheel diameter. And this is going to be measured in inches. Notice again that our data extends over and beyond column number A. We're going to double left click on it, auto extend that over. In cell B1, we are going to type in 29 inches. We're going to go back to row 1, this time right clicking on it and going to insert one row below it. In cell A2, we are going to type in circumference. In cell B2, we are going to type in our mathematical formula to find the circumference of a wheel. As mentioned before, a mathematical formula in Google Sheets always starts with the equal sign. To find the circumference, it is the diameter multiplied by pi. We are going to click on cell B1 as our diameter, the multiply sign, and we are going to type in pi. After you type in this formula, press enter on the keyboard. Notice cell B2 is 91.1 inches. Now that we have our circumference, what we want to do is create a new column and type in the distance per gear ratio that our bicycle will travel. I'm going to go up to column C, right click on column C, and go to insert one column to the left. Going down to cell C5, I'm going to type in a new mathematical formula. In our gear ratios assignment, we have discovered that we need to take the inverse of our gear ratio and multiply it by our circumference to get our distance per revolution. We are going to type in a mathematical formula to do this. I'm going to put in some parentheses. 1 divided by our solution found in cell B5 in parentheses, and we're going to multiply that by our circumference. And then press enter. Notice for one revolution of our input gear, our bicycle will travel 101 inches in distance. Again, to copy this formula, we can drag the handle in the bottom right hand corner. Just like before, we have a couple little errors we need to address. What we're going to do is go back to our original formula, and notice we need to put an absolute identifier in for our circumference. This time we are going to place that $sign in front of the column and also in front of the row number, because we want to identify this exact cell. After you've done this, press Enter on the keyboard and drag down your formula again. Double check your data. It should look very similar to mine. Now that you have your formula, what we're going to do is go back to cell C5, and we're going to go up to our formula bar, highlight this information, and copy it by pressing Control C. We're going to go up to column D, right click on it, and insert a column to the right. We are going to go down to cell E5 and paste our formula in that cell. Notice, however, it is still referencing the data from this area. We do not want that. We're going to modify this particular formula and change the column identifier from the letter B to the letter D. Afterwards, press Enter on the keyboard and copy your formulas down. Once you've done this, we're going to go over to cell G5, paste our formula again, and change our column identifier from B to F, and press Enter on the keyboard and copy that down for each row. Notice, however, we need some labels here so we understand that this is the distance the bike will travel for each gear. We're going to type in our label. Up here, and we are going to resize our column. I'm going to copy our label and paste it in here and just change our numbers out and resize our column. Notice very quickly we were able to calculate the distance our bicycle will travel in each particular gear. Let's jump back over to our gear ratio assignment and look at question number 3. Question number 3 is asking us to calculate how fast the bicycle will travel in both miles an hour and kilometers per hour at this particular RPM. We're going to jump back into our spreadsheet and add this information in. Just like before, we're going to go up to row number 3, and we're going to insert a row above it. We're going to label cell A3 as our RPM, and cell B3 will be 80 RPMs. Just like before, we're going to add another column in between C and D. So we're going to right click on D and insert a column to the left. Now that we have this blank column, we are going to calculate in miles per hour how fast our bicycle will travel at this particular RPM. We are going to type in our label, MPH, which is miles per hour, per 40 teeth. In our gear ratios assignment, we have learned that speed is calculated by our revolutions per minute multiplied by the distance per revolution. However, when we do this, our answer will be in inches per minute. We want to be in miles per hour. So in addition to calculating our speed in inches per minute, we also need to do a unit conversion. We are going to calculate all that in one particular formula. As stated before, our formula will start with the equal sign. Once we have our equal sign, we are going to reference cell B3, and this needs to be an absolute cell. So we are going to put in the dollar signs first. We are going to multiply that by our distance per revolution. And we are going to put in some parentheses here because we want that to be calculated separately. So this number here will give us inches per minute. We need to multiply this by 60 minutes in an hour. And lastly, we need to divide it by how many inches there are in a mile. There are 63,360 inches in a mile. And afterwards, press enter on the keyboard. Notice for this particular gear, at 80 RPMs, this bicycle will travel 7.7 miles an hour. Just like before, we are going to copy this formula to each particular gear. Notice as our output gear gets smaller, the bicycle will start to travel faster. Just like we did in calculating our distance per revolution, we are going to come up here and copy our formula, add a new column, and paste our formula in. Once we've pasted our formula, we need to change our column identifier from C6 to F6. And then drag our new formula down. Before we move on, we are going to type in our label. And we're going to move on to 22 tooth chainring. Just like before, we're going to paste it. And we are going to change our column identifier from C6 to I6. Copy this down and type in our new label. Now that we have our miles per hour calculated, we want to do a unit conversion to kilometers per hour. What we're going to do is come up to column D, right click on it, and insert a new column to the right. We're going to type in our label of kilometers an hour, and underneath it we are going to type in our mathematical formula. What we're going to do is we are going to reference our miles per hour, and we are going to multiply it by 1.60934, and then press enter on the keyboard. Once you've typed that in, we're going to drag our formula down, and just like before, we're going to copy our formula and move on to 30 teeth. We're going to click on column I, and we are going to insert a column to the left, paste our formula, and change our column identifier from the letter D to the letter H. Just like before, we're going to drag our formula down and type in our label. Now that we have calculated our kilometers an hour for a 30-tooth chainring, we're going to move over to a 20-tooth chainring and paste our formula in again. And again, changing our column identifier from the letter D, this time to the letter L, and then drag our formula down, copying it in, and lastly, creating a label for our row. One thing I forgot is how many teeth there was in here, so I'm just going to go back and add that in now. So very quickly, you can create a spreadsheet and it calculates everything that you did in your gear ratio assignment. What I like about spreadsheets is you can come back up to this information here in our upper left-hand corner, and we can change things like our wheel diameter. Say if we were dealing with an older mountain bike that had a 26-inch wheel, we can type that in, and notice all of our data will change for that particular wheel size. Say if our RPM changed also from 80 revolutions to 100 revolutions, our data will automatically update. Now that we have our spreadsheet, what we are going to do is we are going to create a duplicate spreadsheet. To do this, we are going to go down to sheet number 1, right click on it, and go up to duplicate. We are going to rename this to My Bicycles Gear Ratios and press enter. Notice that these two sheets are identical and our formulas are still there. Now that we have a spreadsheet for My Bicycles Gear Ratios, what we're going to do is insert 2 new columns, and we want these columns to be to the right of distance per revolution. So I'm going to right click on distance per revolution and insert 1 to the right and insert 1 to the right again. We are going to create some new labels for these. This one is going to be labeled as measured distance for a 40 tooth, and the one next to it will be percentage air for the 40 tooth. Now that you have your spreadsheet, what you are going to do is you are going to measure your bicycle's wheel diameter. You are going to update your wheel diameter in this particular cell. For example, my bicycle's wheel diameter is 27 3/4 inches in diameter. For the sake of this assignment, you will change your RPM to 80 RPMs. Afterwards, you are going to count all the teeth on each particular gear on your bicycle. Make sure to include every cog on the rear wheel and every chainring on the crank. After you've done this, you will notice that your data will automatically update. You are going to shift your bicycle into each particular gear, and you are going to push your bicycle backwards 1 revolution of the crank arm. You are going to measure the distance your bicycle travels in that particular gear. You will type in the distance that your bicycle travels in these respected cells. And so forth. Lastly, what you want to do is you want to compare your actual measurements to the calculated number. To do this, we are going to type in a formula in this particular cell. This formula is equal to our calculated number minus our measured number in parentheses We are going to divide that by our calculated number, and then we are going to multiply this by 100 to get us a percentage. For example, this number will be 1.9% off. Once you've typed in your formula, just like before, you can come in and drag your formula down to the rest of your gears. Now that we have these two columns in, we need to do the same thing for however many chain rings you have. We are going to go to this column and add in 2 additional columns. This time what I'm doing is I'm going to copy all the data in these particular columns by clicking on the column header, and then Control C, click in column L, and Control V. We're going to update our labels, and then we are going to delete the data that exists in here. Afterwards, just like we've done before, we need to update the cells that we are referencing to. Once we click on our cell, we notice that we are referencing K6 minus L6. So by pasting our formulas in from these columns over here over to these new columns, Google Sheets recognized that we wanted to represent these new cells. We're going to repeat the process again, moving down to 22 teeth, and again pasting our data in from our original formulas. We're going to update our labels. These are for a 22 tooth chainring. And then delete our data and double check our formulas. And notice we are representing the correct cells. Now that we have our spreadsheet, it's up to you to fill in your bicycle's information into the spreadsheet, and it will automatically update for you.